All right, now we can head over to the Pacific, talking about the El Nino Southern Oscillation. So hopefully you've heard of El Nino and its counterpart La Nina. These are climate patterns in the Pacific Ocean that do affect weather worldwide. Even what's happening in the Pacific does indeed impact the weather we have here in Georgia. And whereas the AMO oscillation was about 70 years, the frequency of the Enso oscillation is only 2 to 7 years. So it's a much, much faster oscillation. And you can see in this image here, we've got observational data going all the way back to 1950. And you can see, right, that 2 to 7 year cycle. Notice that the cycle is a little chaotic, and we're not very good at predicting Enso because of this chaotic nature. We're still, research is still out trying to figure out exactly what modulates this cycle. Okay? But right, we have La Nina and we have El Nino. And what happens during these two time periods that during El Nino, the Pacific jet stream is extended and falls to the south of us, right? Coming from the Pacific, it goes along northern Mexico, through the Gulf, and across Florida. And when this happens, where that Pacific jet stream is, it gets wetter. So where we're at during El Nino years gets wetter. The area just north of us gets drier, and even farther than that, north going up into the northern US and Canada, gets warmer during El Nino years because of that low pressure in the North Pacific Ocean. Now, during La Nina years, that switches and we get high pressure in the North Pacific Ocean. And this causes the polar jet stream to get a little wonky and a little right, curvy. This causes it to become colder and wetter in the Pacific Northwest and nearby Canada. And it causes us down here in Georgia to get warmer and drier. So for us in Georgia, El Nino equals wet, La Nina equals dry and warm. Right? But you can see how these oscillations in the Pacific Ocean affect weather all over North America. Now, looking at all the climate models and the best evidence we have, there is high confidence that Enso will remain the same and remain as the dominant mode of interannual variability in this future. That means on the short term, from year to year, right? For example, comparing 2023 to 2024, those interannual, just yearly differences are going to be dominated by Enso. That means you have to look at a longer time period, right? Multiple years, decades, to see the overall trend of climate change imprinted on top of this smaller frequency Enso cycle. But even though the cycle itself is expected to stay the same, we do think that an increased moisture availability due to a warmer climate and the associated precipitation variability on regional scales, right, the amplification of the water cycle is going to intensify. So the cycle will remain the same, that 2 to 7 year cycle, just the intensity of it is going to get more extreme. So during El Nino, even wetter, and during La Nina, even drier for us here in Georgia.